Find Maclaurin series expansion of the x cube. So we're going to need the first, second, and the third derivative. So first it tells us that f of x is 1 plus x squared times the sine of x. This is f of x. F of x is 1 plus x squared times the sine of x. So first now we need to find what is f of 0. So f of 0 means we're going to substitute x as 0. Subbing in x as 0, we're going to get 1 plus 0 squared. 1 plus 0 squared is 1, but then times the sine of 0 is 0. So f of 0 is 0. Next we need to find is f prime of x. To find f prime of x, we're going to use product rule. Using product rule, it is keep the first times the derivative of the second. So it's 1 plus x all squared. Keep the first times the derivative of the second, which is cos x. Plus keep the second, which is sin x. Times the derivative of the first. When we differentiate the first part, we're going to get 2 carry down the power, subtract 1 from the power. All right, so that's what we're going to get. So now after we get that, we can go ahead and find what is f double prime of 0. And so f prime, not f double prime, f prime of 0 is equal to, we'll plug in x as 0 and we get 1 plus 0 squared is 1. 1 times cos 0 is 1. And then over here we're going to get 0, so f prime of 0 is 1. Now we can go further to find what is f double prime. So to find f double prime of x, again we're going to use product rule. Differentiating 1 plus x squared cos x, we keep the first to get 1 plus x all squared times the derivative of the second. When we differentiate cos, we get minus sine. So we get minus sine x plus keep the second. So we're keeping the cos x now plus keep the second times the derivative of the first. When you differentiate the first, we're going to get 2 carry down the power, subtract 1 from the power, so it's really 2 plus 2x plus over here now is differentiating this using product rule. It is keep the first, which is sine x, times the derivative, keep the first times the derivative of the second. Differentiating 2 plus 2x is 2, plus keep the second, which is 2 plus 2x times the derivative of the first. Now when you differentiate sine x, you get cos x. You get 2 plus 2x cos x. All right, so what does that mean? This is f double prime of x. All right, so now we just need to plug in 0 to get that. F double prime of 0 is going to be equal to, we're just going to plug in 0 now. All of this is 0. The cos of 0 is 1. And then this is 1 times 2 is 2. Then this part is 0 plus cos of 0 is 1. So this becomes plus 2 times 1. So this becomes 2 plus, right here again, it is 2. So 2 plus 2, which is 4. So that's f double prime of 0. Now we need to find f triple prime. Oh gosh, differentiating this 3 times. F triple prime of x is going to be equal to, differentiate this, keep the first, which is minus of 1 plus x all squared. Keep the first times the derivative of the second. When you differentiate sine, you get cos x plus you keep the second, which is sine x, times the derivative of the first, and the derivative of the first is minus 2 minus 2x plus, we're going to differentiate this part now, cos x plus 2 plus 2x by keeping the first, which is cos x times the derivative of the second, which is 2, plus keep the second, which is 2 plus 2x, times the derivative of the first. All right, let me not making any space there, so let me write it down. Carry it down here, plus keep the second, times the derivative of the first. And then when you differentiate cos x, you get minus sine. Plus, when you differentiate sine 2x, you get 2 cos 2x, 2 cos x, because sine x times 2 is 2 sine x, plus keep the first, product rule again, keep the first, times the derivative of the second, 2 plus 2x, keep the first, times the derivative of the second, which is minus sine x, plus keep the second times the derivative of the first. Derivative of the first is 2, and we'll keep in the second, cos x. So what does that mean? That means that f triple prime of 0, f triple prime of 0 is equal to, plugging in x as 0, we're getting, this looks like 0 here, that's minus 1. 0 here is 0, plugging in 1 here, that's 2. These are all zeros, plus 2 again. Plugging in 0 here, that's plus 2 again. So this works out to be 5. So now by Maclaurin formula tells us that f of x is equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 plus f triple prime of 0, f triple prime of 0 times x cubed over 3 factorial, which is 6. All right, that is f of x. Now we found f of 0 was 0 plus f prime of 0. What was f prime of 0? F prime of 0 was 1. So it works out to be plus 1 times x, which is x, plus f double prime of 0. F double prime was 4. It works out to be plus 4x squared plus f triple prime, which is plus 5x cubed. Oh, remember this is being divided by 2 plus 5x cubed over 6. So this is the answer. This is f of x. Nice and easy, soft. All right, now question 4. Let's go to question 4. So question 4, it is saying, for the binomial expansion, show that the ratio of the x to the 6th term and the x to the 7th term is 3 over 4x. So first and foremost, you have this. You have 2x plus 3 to the 20th power. Now, to find the thing with the x to the 6th power, it needs to be 2x to the 6 times 3 to the 14th power. All right, and remember it's n choose r, so n is 20, so this is 20 choose 14. So 20 choose 14, 2x to the 6 times 3 to the 14, and that will be the term with x to the 6. So this is the x to the 6 term. So let's work out what this equal to. 20 choose 14, 2x to the 6 times 3 to the 14. 20 choose 14. That's a very big number, so I'm not even going to write that out. I'm just going to write 20 choose 14. 2x to the 6, 2 to the 6 is, I think that's 30, 64. 64 times x to the 6 times 3 to the 14. 3 to the 14. That's a big number, so I'm just going to write times 3 to the 14. All right, then I need the x to the 7th term. And then the x to the 7th term. The x to the 7th term is going to be 20 choose, this looks like 13 times 2x to the 7th power times 3 to the 4th, 3 to the 13. All right, that's going to equal to 20 choose 13 2 to the 7th is 128, so that's 128 x to the 7 times 3 to the 13. To find their ratio, you're going to do a division of these two terms. So you're going to do a division to get their ratio. So put in a calculator 20 choose 14 over 20 choose 13. That's going to be this part over this part is 20 choose 14 divided by 20 choose 13. This part works out to be a half. So this part works out to give you a half. This part here. And I need to work out 64x to the 6 over 128x to the 7. That part gonna ask you give us a half. 64 over 128 is 1 over 2. Then x to the 6 over x to the 7 is 1 over x times 3 to the 14 over 3 to the 13 is 3. So the ratio works out to be 3 over 4x. So that's how you show it. So that's the ratio of this x to the 6th term to the x to the 7th term. So show it soft. Nice. Now the next part says determine the first 3 terms of the binomial expansion 1 plus 2x to the 10. Determine the first 3 terms, all right? 1 plus 2x to the 10. So the first 3 terms is going to be, it's going to be the first term, which is 1 to the 10, plus you choose 1 of 10, and it's going to be 1 to the 9 times 2x to the 1 plus 10 choose 2 times 1 to the 8 times 2x squared. This is, so when you simplify that, 1 to the 10, 1 to any number is 1. Then you have plus 10 choose 1 is 10 times 2x. That's plus, this is 1 plus 10 choose 1 is 10. 10 times 1 is 10. 10 times 2 is 20. So it's 1 plus 20x plus 10 choose 2. 10 choose 2 is 45. 45 times 2 squared is 180. So this becomes plus 180x squared. 180x squared. That is 1 plus 2x to the 10. All right, now since that's 1 plus 2x to the 10, that's part 1. Next part says, hence obtain an estimate for 1.01 to the 10th power. So to do the estimate part now, all right, we need in here so to be 1.01 to the 10. So what we need 1 plus 2x, we need that to be equal to 1.01 rather. And so in reality, we're saying that 2x is equal to 0.01. And so in reality, we're saying that x is equal to 0.01 divided by 2. That looks like 0.005. All right. That's what we're saying is x. X is 0.005. Okay. Now that x is 0.005, now we can go ahead and compute what this is going to be. So 1.01 to the 10th power is going to be equal to, we're going to substitute in 0.005 in this equation to get that it is equal to, let's plug that in. It's equal to 1 plus 20 times 0.005 plus 180 times 0.005 squared. When you work that out, you're going to get I'm getting 1.1045. That's what I get for my answer. All right, nice and easy, soft. Nice. And this is a whole of 7 marks to do nothing. Okay, now let's look at the next part of the question. The next part of the question says, show that n factorial over n minus r factorial times r factorial plus n factorial over n minus r plus 1 factorial times r minus 1 factorial is that. So let's do that proof. So first thing, we're going to start with the left-hand side. N factorial over n minus r factorial times r factorial plus n factorial over n minus r plus 1 factorial times r minus 1 factorial, and that is equal to n plus 1 factorial. All right, let's do the proof first before we write over this side. So now to do this now, all right, first thing we need to do is find the common LCM. Anytime you're doing addition of two fractions, you find the common LCM. The common LCM is going to be n minus r factorial. Well, n minus r plus 1, n minus r plus 1 factorial r factorial. Now I just want to write this down, all right? We know that, for example, if you had a number like 5 factorial, 5 factorial can be written as 5 times 4 factorial, don't it? Yeah, man. So the same way, think of n minus r factorial. Think of this as k. Think of n minus r factorial as k. So it's like you have k factorial, and this is like a k plus 1 factorial. So k into k plus 1 factorial leaves just k plus 1. Leaves just k plus 1. So right here, this into this into this leaves k plus 1, which is n minus r plus 1. Because that's k. So it leaves n minus r plus 1, and all of this is multiplied by n factorial plus, think of r factorial now. You have r minus 1 factorial. R minus 1 into r factorial, just leave r. This is now n factorial times r. Now both of these in the numerator have what in common? That looks like n factorial. So we're going to factor out n factorial in the numerator. And what we're left with is n minus r plus 1 plus r. So we're left with n minus r plus 1 plus r. Now doing this now, what are we going to get? And then we're dividing that by, this looks like n minus r plus 1 factorial times r factorial. Now the minus r and the plus r cancel each other. So it works out to be n minus r plus r. That just works out to be n factorial times n plus 1. It works out to be n factorial times n plus 1 over n minus r plus 1 factorial times r factorial. But then n plus 1 times n factorial is n plus 1 factorial. This is n plus 1 factorial. That's how we prove that question solved. That's n plus 1 factorial over n minus r plus 1 factorial times r factorial. So that's how we do that question. The proof done and dusted, solved. So you can just tell them, too easy. Nice. Now let's look at part C.